Okay, so what we want to do now is we're going to create an extended ACL, and what we want to do is we're going to simulate a couple of servers up here that we'll put different internet sites on, and then we're going to limit our traffic from inside being able to access those. We could also use extended ACLs, if we know that a hacker from up here is trying to come in, we can use an extended ACL to limit that traffic as well. But in this example, we're going to limit traffic from down here getting out to this particular server. To set this server up here, we're going to go to services, and you can get as complex as you want to here, but let's just take off this welcome to packet tracer. And let's just say that this one is google.com. Actually, let's change this one. .com. And we can actually take off this one here. And all of that. So we'll overwrite that. And then we can go to the desktop here. We'll go to the web browser, and we can do localhost here. And we can see, no, that's not going to misspelled com here. So let's just go ahead and take that back up there. Because that's going to bother me. Now, if you look back at File Manager here, you can change logos and do all sorts of things, but we're not going to really worry about that here. Now we do need to cable this up. We need to do a crossover. And we only have one fast Ethernet here, so I'm going to connect this one. If you need to connect another device here, then you're going to have to go in and shut down this machine. So actually, let's go ahead and go in here to physical. We can turn this off now. Hopefully you've saved your configuration before you do this. We can pick up our NM module cover, network module cover, and then we can add in something like a twisted pair fast Ethernet module here, power back on, and now we actually have enough interfaces here that we can connect another server here. What I want to do here is actually bring go back to end devices, and bring another server up here. And maybe we want to go to services here. We'll do index.html. And really, this is the only thing we really need to worry about here. Let's do that and save that there. And now we can go connect, crossover, fast Ethernet here. And now we have another fast Ethernet 1.0 down here. On the configuration thing here, let's change the display name. Shoot, which one was this one? So services. And this is Facebook. This one we will call Google. Okay, so that gets that's the servers physically up here. Now we also have to do a couple of other things. We're going to have to put an address on here. I'm going to put the gateway as 1.1.1.1, and we'll do 1.1.1.2 here, and we'll do our 255.255.255.0 here. And for Google, let's do 2.2.2.1 for the gateway, and 2.2.2.2. And I'm just putting everything to Class C address mask, just so that I know that that's what I'm doing for all of them. Okay, so here on the router, we have to kind of figure out the IP address, or which interface is going which direction. And it gets a little bit hard, but if you pick this up and move it, you'll notice that the 10 is moving. And so Facebook is on our 10, and Google is on our 01. And I think we had okay, so our IP address here is going to be 1.1.1.1. /1. Two dot two dot two dot one. And we'll do a no shut here. Okay, so when we do a show run here, we'll notice that we have a running OSPF process 100 and area 0. So let's go back in and add our 2 new routes in. So we'll do router OSPF 100. Let's have to spell things correctly. We'll do network 1.1.1.0. Area 0. Oops. Okay, so now we have our routes set in here, and okay, so let's do ping 1.1.1.2, and that's this one here, and then we'll do 2.2.2.2. And that's okay. So we always again are going to make sure that we can ping from the device that we're actually trying to stop the traffic from. So we'll do ping .1.1.2. And then while you're on the desktop here, we can go to the web browser and do .1.1.2. And we got Facebook agreement. That's really messy. I should fix that, but not going to worry about it right now. And then let's do 2.2.2.2, and that's google.com. That's the reason I like to take all that other stuff off. Okay, so now we have this particular access, and so we're ready to really start with the point of what we're trying to do here, which is to allow one of these to access the one particular server and maybe the other one not. Now, with extended ACLs, well, let's first say that with standard ACLs, we put them as close as we can to the destination because we don't want them to block traffic inadvertently. Now, with extended ACLs, you can put them anywhere in the path of the packet. So if something was going from here, then you could put it in going here, out going here, in going here, out going here, incoming here, or outgoing here. Now the reality is that we don't have control of the router that Facebook is connected to or Google's connected to, and so what we want to do is efficiently as possible. There's a couple different ways of thinking about this. Do we want traffic to go from here all the way up through here, get all the way up to here, and then be deleted, or should we do it as soon as possible? And a lot of times the answer is as soon as possible. There's other factors though. I mean, if we already have ACLs here and we feel like the processing power of this router is not really sufficient, because every time we run an ACL, every time it gets triggered, it is using processing power. So maybe we want to balance some of that processing off onto this router. Maybe we only want one place where we have all of our ACLs, and that works as long as we have to keep in mind that we can have one ACL per interface, per direction, per protocol. And so that can sometimes be an issue that makes you think about where else you might place it. So I'm going to place mine here on the Fremont edge, just to make it a little bit easier. Now, I don't remember exactly which of these VLANs that I said that I was going to prohibit traffic from. So what we're going to do is we're just going to say we're going to prohibit it from the .60 network getting to Google, and that will be our operational understanding as we're moving forward here. That might not be what I've said in the past. Let's go ahead and work with that. Now, standard ACLs go from 1 to 99, and then from 100 to 199 are extended ACLs. So let's just call this one 101, and we are going to deny TCP. So if you are specifically denying a particular service like web services is a TCP subprotocol. You might have UDP here if you were denying like VoIP traffic or video traffic, etc. So you have to know a little bit about all the different protocols and kind of what subset of TCP/IP stack they are. If you're denying everything, then we will do a IP here instead of TCP. So anyway, deny TCP. We're going to deny 170.32, was it? dot 60.0. So anything from that particular VLAN, we will have a wildcard mask here. So this portion, this first portion here, is the source address and subnet mask or wildcard mask, and then we'll do the destination address. We can just do the whole network here if we want to. And web traffic goes on port 80. So what we've done now is we've denied traffic from that VLAN going to the 1.1.1 network for web browsing. We have not denied it for pinging. Now, anytime you have an access control list, you have to have always at least one permit statement, because the final statement is always this implicit deny. And it starts processing from the top and moves down until it meets the statement. So it's kind of like an if-then statement. And so we need to do access list 101 permit IP any. So our protocol is IP, and then our source is any, and our destination is any. And then, of course, we need to go in actually and do interface. So let's do this incoming on the FA0/0. So let's do int FA0/0. We'll do IP access group 101. Okay, so let's just assume that works. And again, it was the .60, so I think this is the .60 device here. So what we're going to do here is we're going to ping. So we had that up here already. This and that still works. But now let's do 1.1.1.2. And then we found out that that no longer works. 2.2.2.2. That's still allowed. And that is extended ACLs. Again, you want to think about where it's most efficient and effective for you to put that, and you do want to not just put it some random place, but to justify. And so here, this is the edge router, and that's the reason I chose that. But it can be anywhere along the path of the packet. And so again, the packet's coming in to the Fremont internal here. It's going out here, in here, out there. And anywhere along the path of the packet is an acceptable place to put it, but you do need to justify where you're putting it. Okay, and that's it.